In today's video, I would like to introduce a very nice problem regarding the calculus 3. Here is the following equation differential. We have the second derivative function of this variable plus 2x is multiplied by the first derivative function plus 2 is multiplied by y equals 0. Satisfy two conditions. When we have y to the 0 equals 1 and y prime at the point 0 equals 0. Okay, now let's jump into the solution. I'm going to remind you about the power series. So we know e to the x as an exponential function equals the sum as n goes from 0 to plus infinity of x to the n over n factorial. Okay, so in order to prove this one, you are going to use the Taylor series. If you guys want to take a look at this proof, I did many videos regarding these functions by using the Taylor series and Maclaurin series. So I know it's hard to find them, but at the end of this video I can add them to the comment section below right after this video. Since we know this formula here, I'm going to use the power series to solve this differential equation. So let's set y equals the sum as n goes from 0 to plus infinity of e sub n is multiplied by x to the n, like this. So the purpose of using this power of series to find out e sub n, okay, to make the relationship between the first one and second one. This one is the same as the generating function. Okay, you can use the generating function at any time you want in order to find e sub n. You making like a circle, so you working around, and then at the end you will find this unknown variable, which is e sub n. Okay, so this is the purpose of this one. I'm going to calculate the first derivative function of this one. So we have y equals the sum as n goes from 0 to plus infinity. E sub n is multiplied by x to the n. So I'm going to calculate the first derivative function of this one. Is giving me the sum as n goes from 0 to plus infinity of n is multiplied by e sub n is multiplied by x to the n minus 1, like this. Okay, then since I have this 2x, I'm going to multiply both sides by 2x. So I have here 2x y prime equals as n goes from 0 to plus infinity of 2n is multiplied by e sub n is multiplied by x to the n. This x is going inside this one to make x to the n, okay, to change this order to x to the n. So I'm going to leave this one as it is. I'm going to pick up this one and derivate it one more time to have the second derivative function. So we'll have the sum as n goes from 0 to plus infinity of n minus 1 is multiplied by n is multiplied by e sub n is multiplied by x to the n minus 2. Okay, here is the thing. We have the power x to the n, we have the power x to the n minus 2. So in order to change this power to this one, I'm going to re-index this one. Okay, so I'm going to change n to the n plus 2 in order to get the re-index the same power here to make the x to the n as a common factor. If you take a look carefully at the first term and the second term, n equals to 0 is automatically 0. Replace n with 0, get 0. Also the second term n equals 1 equals 0, because if you replace in here number 1 n with number 1, you get 0 also. So if I'm going to leave them like this, doesn't affect our calculation because they already are 0. Okay, so we'll have as n goes from 0 to plus infinity, this n minus 1 becomes n plus 1 as I'm changing this one to n plus 2. This n becomes n plus 2. This n becomes e sub n plus 2. This one becomes x to the n. Okay, like this. I'm going to add all this stuff together to make this equation equal to 0. Okay, So I will have the following. I will have the second derivative function plus 2 times xy prime plus 2 times y equals, I'm going to put everything under one sum as n goes from 0 to plus infinity. I'm going to put this one first. So we'll have n plus 1 factor n plus 2 is multiplied by e sub n plus 2 plus the second one. The second one will have 2x is multiplied by y prime, which is this one. Since this one and this one have the same coefficient e sub n, I'm going to put e sub n as a common factor for this one and this one. Plus, remember, we have 2 times y and plus 2 times xy prime. So I'm going to take number 2 and e sub n as a common factor for these two terms. So which means I will have 2 is multiplied by this n. This one was multiplied by number 1. Both terms are multiplied by e sub n as a coefficient. Okay? So the whole thing is multiplied by x to the n, which equals to 0. Okay? If this sum equals to 0, which means this bit equals to 0. By moving over this one to the right and leave this one to the left, e sub n plus 2 equals minus 2 is multiplied by n plus 1 over n plus 1 is multiplied by n plus 2 is multiplied by e sub n. So I get this n plus 1 cancelled out, so which means I will be left with this one, e sub n plus 2 equals minus 2 is divided by n plus 2 is multiplied by e sub n, like this. Okay? So I have ended with this nice expression. So I'm going to bring this one at the top and continue solving our equation. At this moment, I'm going to use these initial conditions in order to determine the e sub n and e sub n plus 2. This recursion is an odd or even. Okay? So by using these conditions, if I'm going to replace x with 0, I get y of 0, and replace n with 0 here, I get the first term e sub 0 is multiplied by x to the 0, which is 1. I get e sub 0 equals 1, so I will have e sub 0 equals 1. I'm going to check e sub 1. If I'm going back to this function as a derivative function and replace x with 0, I get e prime of 0, which equals to 0. Then replace n with 1. Okay? So I get here e sub 1 equals x to the 0. Okay? So which means e sub 1 equals 0. So I get here e sub 1 equals 0. If e sub 1 equals to 0, by replacing n with number 1 here, this one is 0, which means e sub 3 equals 0. As you're replacing, then we get the next one, e sub 3. We get e sub 3 equals to 0. Here you get e sub 5. E sub 5 equals 0, and e sub 7 equals 0, and so on and so forth. So the all add and x equals to 0. Add equals to 0 based on this condition. So which means this recursion becomes even. So since this is even, I'm going to replace n with 2n. E sub 2n plus 2 equals minus 2 is divided by 2n plus 2 is multiplied by e sub 2n. So I get here number 2 cancelled out, which means I get here minus e sub 2n divided by n plus number 1. So what I'm going to do now, I'm going to use the recursion. I'm going to use the recursion one time here to see e sub 2n, because what I have done here, I replaced n with n minus 1. Okay? If I'm going to do that by multiplying here this one by 2n minus 1 plus 2 is giving us 2n minus 2 plus this 2, which is to n. That's what I have done here. Okay, so this one becomes 2n, this one becomes minus 1 over n, because n replaced with n minus 1. This one becomes minus e sub 2n minus 2. As you replace n out with minus 1 and distribute out this one, is giving us this one. This is one time recursion. I'm going to use the second time recursion. So we'll have the same thing, minus 1 over n is multiplied by minus 1 over n minus 1 is multiplied by e sub 2n minus 4. This one will be all the way down on the same pattern. Minus 1 over n is multiplied, minus 1 over n minus 1 is multiplied by minus 1 over n minus 2 is multiplied by e sub 2n minus 6, and all the way down to the minus 1 over 1 is multiplied by e sub 2n minus 2n, like this. Okay, it becomes e sub 0 equals 1. So if I'm going to put the stuff together here, so I get here e sub 2n plus 2 equals, with this minus 1 with minus 1 becomes minus 1 n plus 1 divided by this stuff, n plus 1 is multiplied by n minus 1 is multiplied by n minus 2, and all the way down to 3 to 1. This is the factorial. Okay, so you get here minus 1 to the n plus 1 is divided by n plus 1 factorial, like this. Okay, by going back to the original equation, so I'm going to replace this e sub n with e to n, e sub 2n here, like this. Okay, but I have e sub 2n plus 2. I'm going to reduce this one to e sub 2n. So this one is giving us e sub 2n equals minus 1 to the n is divided by n factorial. Okay, here I just replaced n with n minus 1. If you distribute this one, is giving us e sub 2n. Then this one, instead to have n plus 1, will have n. I'm simply going to replace this one into this one. Y equals the sum, as n goes from 0 to plus infinity, of this one minus 1 to the n over n factorial, okay, is multiplied by x to n. So by using this formula here, by replacing minus x here with x squared, because I'm going to raise this one as a power, using this one like on this form, this one becomes here 2n minus 1 to the n. Okay, like this. This n becomes like this. It's giving us exactly this one, e to the minus x squared. Okay, this is the solution for this equation. Okay, so I have ended this video. If you have any question or suggestions, put it in the comment section below. Don't forget to support us with a like and subscribe. Thank you for watching. I will see you next video. Bye.